Welcome to our Serverless Days Meetup. Ooh, am I sharing already? I should present this. So as you can see, we are very well prepared as usual. Thanks for joining anyway. So if in case you are new to Serverless Days Amsterdam, you can watch our stream on YouTube and on Twitch. Just look for Serverless Days Amsterdam. And we also have a Discord channel in which we will be having a discussion. The speakers will be there, the hosts will be there. So anything that you want to talk about, go to Discord for to get an answer to your questions. You can also drop your questions for the speakers after the talks in Discord or Twitch. Oh, great. Yeah, I'm getting the notifications over there. So my name's Lian Lee, in case you're new to this. I'm a cloud native engineer at Container Solutions, and thanks Flora for adding that I'm also kind of a big deal. I think that is very important to state.
Hey, you should know.
Yeah, thanks. I don't talk about myself enough. So I'm the organizer of this first Serverless Days conference, or the co-organizer, and also now the second Serverless Days conference co-organizing. Also meetups, that's all our little group of awesome people here. And okay, I fixed now Google Slides.
And after
No, it wasn't the wrong screen. I had to move this away and then remove it back there. Sorry about that. Cool. All right. Giving it over to you, handing over to you, Flora. Please tell us more about yourself.
Awesome. So hi, my name is Floor. I'm a developer relations program manager at Microsoft. So also welcome from my end. Indeed, we did the Serverless Days Amsterdam conference just, what is it, a month ago? It seems like last week.
It was like 2 weeks ago. No, it was about a month ago. It was 7th of May, I think, or 8th of May.
8th, for sure.
Yeah.
Yeah, and it seems like such a short while ago. Luckily, the recording is up to, for your viewing pleasure on demand. I saw that Leon had some Netflix open, but maybe this is something that you want to watch instead if you have some time left over. We're going through some slides, I think, aren't we, Leon?
Yes, we will go through some slides. The usual slides that, if you're familiar with Serverless Days, we go through kind of like every time. So yes, again, this is the online meetup edition that we are having because of all the stuff that is going on right now, and we hopefully will return to some cool hybrid-y version of half online, half offline. We don't really know yet, but I think we learned that online also has its advantages, and so we're gonna think of something cool once this is all over and we get to go outside again. So just want to say really quickly about Serverless Days that this is a global, not organization, but there are lots of Serverless Days all over the world. Yeah. This is really community. This is about like local people doing something for the local community. And if you are interested, you can go to serverlessdays.io and look for maybe a chapter in your town. If not, you are free to start one yourself. You can reach out to us also, and we can help put you in touch with the right people. And yeah, we'd love to see you also get involved in like our little group if you're interested in that. So this is from this year's Serverless Days conference, which we did online, and hopefully you saw that because it was pretty awesome, I think, for the first online conference that I ever organized, for sure. So this is like one of the sketch notes that we had for the talks. I think they're very, very awesome. We had some amazing hosts. I think, Flor, you changed your hair since then.
I did, yeah. I was I just grabbed one of those hair clippers and just like.
Well, your hair looks great. You definitely are wearing. You're definitely wearing the shirt better than Marek did. I remember there was a short thing on.
Yeah, I have another great serverless shirt. So like, I keep it up. Next meetup will be new shirt again.
I mean, you're just the best with shirts, but you didn't change your costume for the after party, which I did, as shown in this picture, Exhibit A. So yeah, we had quite a couple of users. We had a lot of people engaging on Discord, and I think that was pretty amazing and really fun. And I think I'm sure we're going to do it again. Again, some hybrid-y online, offline thing, because that online thing was pretty awesome as well. Yeah, so that kind of was the conference that, as Flora said before, you can watch on YouTube still, and it's also on Twitch. So if you go to our YouTube channel, it's there for your pleasure. Oh yeah, right. And then the after party, I almost forgot about that. That was also pretty awesome. And Sam Aaron.
About that.
Oh yeah, maybe you should talk more about that, Flora.
It was great. No, wasn't it? Actually, big question. Can we still watch the recording of the after show?
I think so.
That'd be good.
Yeah, it's its own separate video on our channel, so you can exclusively watch just the after party.
Over and over again.
Yeah.
Good.
So, yeah, so that was super cool. We're definitely going to do something like this again. We're hoping that, the meetups will kind of give you like little tastes of like our online doings. So without further ado, this is our agenda for tonight. We're going to start with Dana, who's going to talk about Go Serverless, Azure Functions in Python, and then we're going to have a Q&A session after, which is live. So feel free to drop your questions in Twitch or YouTube. I think we disabled YouTube comments for today, and on Discord, of course. Then we're going to have a 10-minute break, and following that, we're going to have Martha speaking about CI/CD for serverless applications. And of course, we're going to have a Q&A about her talk after that. And then at the end of this, we are trying something actually new for the meetup for the first time, which is that we will be opening a video audio chat on Discord. Just get a little more of a hanging out kind of feeling instead of like typing. Because I have my hands full with like wine, so I need like a video thing working for me. I just want to say one thing about why we also disabled the chat on YouTube. So, I mean, I'm fairly certain that you know what's going on right now, political situation in the States, and we have discussed internally to move the event back, like other events have been moved, to leave space for more important things on social media and such. But we moved this event already once, and we felt that it wouldn't be cool to do it again on such short notice because we literally talked about it yesterday. We think that it would be great if we could use this as a platform for people to come together where we can discuss and share and, of course, talk about these important issues. But then also, I mean, absolutely be aware that we have a code of conduct and we are not afraid to execute it. So if we see, that's also why we disabled the chat on YouTube, because we have our hands full with the 2 other chats. But yeah, we ask you to just be respectful. We totally encourage discussion of all kinds, but like be respectful, don't be hurtful, don't be brilliant to each other. And if in doubt, just take a look at our COC just to make sure that you know what is important to us when we talk to each other. Flor, do you have anything to add to that?
No, but I would love to introduce the first speaker.
Awesome, then let's go ahead.
All right, so our first speaker, as Liana already said, is Dana. She's a data engineer at Linkit and is interested in providing solutions for data-driven companies. She holds a master's degree in robotics. Oh my God, so cool. And computer engineering. And previously, she worked as a software engineer focusing on robotics as well. And in her talk, she will provide us with a quick start for Azure Functions in Python. And she told us that the talk is both useful for Python developers that would like to learn more about serverless and Azure Functions, but also for Python developers, but also for people that already are familiar with serverless and Azure Functions and use them with a language that used it with a language before that is not Python, might want to look into Python. So she'll be covering developing, running, and debugging Azure Functions. And we're ready when you are, Dana.
Yes, thank you for having me. We can start whenever you're ready.
Awesome. Go for it.
Hello, everyone. Thank you for joining my session, and thank you to the organizers of ServerlessDays Amsterdam for organizing today's meetup. Today, I'm going to show you how easy it is to get started with one of the most popular cloud services, the serverless functions, and how easy it is to deploy your application using them. I'm going to focus on Python, and I'm going to show you how you can set up your environment to access the cloud, how you can build your first serverless application in Python, and finally, how you can deploy this application to the cloud. This presentation will be useful for Python developers that don't have experience with the serverless, as well as for developers that have experience with serverless function, but in other languages other than Python. Okay, before we begin, a bit about myself. I'm Dana. I'm data engineer at Linkit and I'm based in the Netherlands. Here you can find my LinkedIn profile in case you want to connect after this session, as well as my GitHub profile where I share open source projects and workshops. I will share the slides from this presentation as well as the code I will present later on my GitHub profile, so if you're interested, please check it out. In today's session, I'm going to talk about 3 things. I'm going to talk about serverless functions, of course, and I'm going to explain what they are, how they work, how you can use them, why you should be interested in them, and how you can find them useful. And then I'm going to show you practically how you can create your first serverless application in Python. And in the end, I'm going to show you some best practices that I often use when I'm working on my own serverless applications. So let's begin. Let's start with explaining what is serverless and how it works. Serverless is just one of the many services the cloud provides. And well, since this is a serverless meetup, I assume that all of you are already familiar with the cloud and its benefits, and probably you've used quite a lot of services of the cloud already. As you probably already know, the cloud is an excellent way to get access to resources and services using a cloud provider of your own choice. For myself as a developer, I think that the biggest benefit is the shift of capacity planning that the cloud offers for me. This means that as a developer, I don't have to worry about servers, managing them, having a storage, dedicated network, etc., just to ensure that my application works properly when it reaches its end users. Another feature I also like is the flexible scaling, which means that I don't have to worry if there will be a sudden increase or decrease in the number of users that use my application. And finally, another excellent feature that the cloud offers is the built-in availability and fault tolerance. When it comes to serverless functions, there are many different options and all major cloud providers offer them. So you can choose between several popular options. Azure offers Azure Functions. Lambda is another popular offering by AWS. Cloud Functions is provided by Google Cloud, and IBM Cloud Functions is provided by IBM Cloud. There are some differences between them, although the underlying idea is the same. You can check it out. I'm not going to focus on that during this presentation, but their documentation is quite extensive and you can easily find these differences online. In today's session, I'm going to focus on Azure because Azure is the cloud I have most of my experience with. So let's begin. So as I mentioned, Azure Functions is just one of the many services that Azure offers. Azure is managed by Microsoft, and Azure Functions is one of the services that's offered. So Azure Functions is a serverless compute service that lets you run event-triggered code. So let's see what this means in a bit more details. So when we are talking about serverless functions, not just Azure Functions, any kind of serverless function, we need to think in terms of events, and this is a bit of a mind shift because our program needs to basically handle these events, detect them, and react to them properly. So there are some terminology we need to understand for Azure. First, we have triggers, and the triggers are the events that trigger the execution of our function. Once we detect a trigger, we know that our function needs to start running and compute something. Then we need a way to use the output from this function, to use the thing that our function processed, and basically use it in another service in the cloud. So we can do this easily using bindings, and this is the way we handle the input and output of data from our function. What's very useful is that Azure provides templates for both triggers and bindings for us, and it's not difficult to understand what this templates contain and how to modify them to our own needs. And I'm going to show you practically how you can do this later. Let's understand triggers and bindings a bit better with an example. Imagine that you have a machine learning service, and this machine learning service contains a neural network that uses images as an input. Before we can use these images in this neural network in the cloud, we need to resize them. So let's say that the serverless function will do this for us. It will resize the images. So we need a way to start it. We need a way to trigger it. We can do this, for example, by uploading the images to a blob storage, and the act of uploading will be the trigger that will start our serverless function. So because there is a change in the blob storage, our serverless function via trigger will start running. So our serverless function will be small, short, and it will finish quickly. It will do only one thing. It will resize these images. And after the resizing is done, we will use a binding to bind our serverless function with the machine learning services and use it there to train our neural network. Okay. So when it comes to triggers and bindings, there are many different options and templates that Azure provides. So there are templates for all this that you can easily generate. Some interesting and useful triggers are, for example, any changes in the blob storage or queues or HTTP triggers. These are some that I use quite often. For bindings, you can connect your function with both relational and non-relational databases, with queues, with blob storage, or you can have HTTP binding. There are many benefits from using Azure Functions. In my opinion, the biggest one is the fact that you can focus on your time on managing and developing your application instead of worrying of the underlying infrastructure. An interesting feature that you need to keep in mind is that you only pay for the time your function is running, not for the time when she is idle or not running. So I mentioned previously that the serverless function, when you create it, it should be short and simple and finish as fast as possible. So this connects to this point because you only pay for the time your function is running. It is in your best interest the function to finish as fast as possible, because you will pay as least as possible. Also, there is a time limit that you need to keep in mind. Your function in Azure cannot run longer than 5 minutes. So yeah, you need to ensure that the functions you create are short and finish as quickly as possible. So you're sure you pay the least as possible and that they will finish in time. Azure, if you deploy your application to the cloud, guarantees that your application will run and scale with high availability. There are many interesting features of Azure Functions that I would like to explain. The first one is, of course, that they offer support for different programming languages. Python actually was introduced quite recently in 2019, towards the end of 2019. And the support started from 3.6, so keep this in mind. If you're using an older version of Python, then you might not be able to use it in your project. So I thought as well that because this is such a recent development, the support was introduced just last year, that there are still a lot of developers that have used serverless functions in Azure. They don't know how to use them in Python, so that's why I created this session. When it comes to Python, it's quite easy to use your own dependencies in a way you're familiar with in Azure Functions. I'm going to show you practically how you can do that later. There is integrated security, and I already show you how easy it is to integrate your code with another services using bindings. There is multiple ways in which you can deploy your application. Like Azure offers a lot of flexibility. You can use the terminal, you can use a plugin for Visual Studio Code, or you can use the web interface of Azure. And for development, you can basically use all the editors you're familiar with, like Visual Studio Code or PyCharm, so not much of a change there. And Azure Functions is open source, so you can basically check out how the code was basically developed, what it contains, and you can contribute as well if you want. There are several interesting application and use cases that you can build with Azure Functions in Python. Especially when we are talking about Python, we have to mention data science pipelines because that's kind of like synonymous with Python, and processing and preparing data for these data science pipelines. Some interesting applications I saw was, for example, using Azure Functions to deploy a machine learning model alongside a scoring script, and in that way you can create an inferencing application. You can, of course, use triggers and bindings to move, prepare, and transform data before you use it in your data science project. And finally, it's quite interesting that you can use event-driven triggers to detect any changes in your dataset, and if that happens, to retrain your model so it can be updated with the latest data. Azure is also really good for automated resource management and integrating systems. For integrating systems, you can use the bindings, and you can, for example, use Azure Functions to monitor alerts that are generated by other Azure services. You can react by events that are captured by other systems, like, for example, service management or monitoring systems. And finally, you can perform scheduled tasks to basically update something in the systems. Azure Functions are also quite often used for IoT data because you can schedule processing of the data there, or you can basically start the function once certain event or a threshold is detected. So everything is quite interesting. So let's see how we can create a serverless application in Python now that we know what Azure Functions are and how they work and what we can build with them. The presentation here focuses on using the terminal because this is one aspect I think it's not very well covered in other presentations and tutorials. I will show you how you can do this on your Mac in this presentation. However, if you go to the link below, there you can find all the steps you need in case you're using Windows machine or a Linux machine. And I'm going to share this link in the end as well, so you will be able to find it easily. Okay, so let's begin. So when we are creating an Azure application in our terminal, we need three things. We need the command line interface installed, and we can do that easily using this command in order to be able to connect to the cloud from our terminal. Then we need core tools, and core tools is the tool that will allow us to run and test our serverless functions locally. Then, of course, you will need an Azure account as well, and you can create one for free using this link, and you will get an initial credit of, I think, around $200 for free, and that's more than enough for the application I'm going to show here. So yeah, please do that as well. Oops. So when we are creating a serverless application, the first thing we need to do is create a template for a project, and we can do this easily with the command you're seeing on your screen now. Here you can see that I provided the name as an argument, function Python HTTP example. It can be whatever you want, of course. And once you run this command, it will prompt you to choose the programming language you're going to use. And in our case, it's of course Python, so I'm going to choose 3. So this command will generate some templates for me, and let's see what these templates look like. So once we run this command, it will create a folder, function Python HTTP example, and 3 files. The host file will contain all the global configuration options that our function will use once we run it. Then we will have the local settings file, and this JSON file will contain all the settings that our application will use when we're running and testing locally. So I'm talking about app settings, connections, etc. Finally, we have the requirements file, and the requirements file is something that every Python developer is familiar with. Basically, this is our configuration file for our Python packages that we install using pip. If you're not familiar with Python, basically this is the way we handle dependencies in Python. After we have the template for our project, we need a way to create a template for our function. So we can do this easily using the following command, and once we run it, you can see that it will prompt me to choose the number for the template. Basically, what kind of trigger I'm going to use to start my function. I'm going to choose 5 because I want to use an HTTP trigger. And then I will provide the name of my function. In my case, this is response text processing. So this function will create another folder within our project, and this folder is called response text processing, in line with what I typed. And it will contain 2 files, the init file and the function file, which is a JSON file. So let's see what they contain. The function JSON file basically provides all the necessary endpoint configuration that we need to start our function and basically bind it with something else. It will identify the startup file, and this is the file that our function will start first once we start it locally or in the cloud. And it will describe all the incoming HTTP requests and responses. So we have HTTP requests and responses in line with what I chose previously for the type of the trigger. And if we have any bindings, they will be here as well. The init file is quite important. Basically, this is our serverless function template that we need to understand first before we want to basically modify it to our own needs. So let's see what this contains. The first thing we have is the library import, and here we have the logging module, which is not mandatory, but I highly encourage you to use it because you will be able to figure out more easily like what's happening in your application. And then you have the Azure Functions module, and then this is of course mandatory if you want to use Azure Functions in Python. Here we can see our main function, and our main function basically takes an HTTP request as an input and returns an HTTP response. This is in line with the type of trigger that I chose previously. We can see that this function is looking for a URL, and then it checks whether a name parameter was provided there. If the name parameter was not found in the URL, we check whether there is a JSON that was provided, and if this JSON contains a name value. If we are able to find this name value successfully, either in the URL or the JSON file, we're going to return a string, like in the HTTP response, which is hello plus the name we found. Otherwise, we will return an error. So let's see how we can start and test this locally. We can use this command, and what this command will do is it will start everything locally, and it will provide towards the end. You can see here an URL with a get and post methods that we can use to test our function. I did this in the terminal with a simple curl request. You can do that in Postman as well, like it's up to you. And what I did is I used the URL that was provided, and I appended the name value I need to use to see whether it works properly. I just used this string. You can use anything you want, of course, and test it. Okay, so this is all very nice, but we are running the function locally and we didn't modify it. So let's see how we can modify it to our own needs and how we can basically deploy it to the cloud. So if you want to use your dependencies, the first thing you will need to do is use a virtual environment. If you're a Python developer, I assume that you're familiar with it. If you've never heard about virtual environments before, if you go to the link I had at the beginning, you will find an explanation about how you can install them and use them. So I will not go into more details here, but basically this creates an isolated environment for our dependencies in Python. And after we have this virtual environment set up, we can install our dependencies and run pip freeze after we have installed all of them. Pip freeze will store all the dependencies that we installed and need in the requirements file that was generated as a template for us at the beginning when I created the project template. So after we have all our dependencies installed, we can start developing our own application. For this use case, I created a very simple natural language processing application. And a good practice is to create a separate folder, separate from the serverless function. So I created my application here, and I have this script called natural language processing, text processing. So in this way, you're separating the logic from the init file, and you can use the init file just to call this function and output its results. So I need to import it. So after I wrote it, I will just import this script in my init file, and the init file will be the one that will run and start once we call our serverless function, and it will basically call the code from this script here. So if you remember, the init file was looking for a name value in either a URL or a JSON file that was provided as an input, and checked whether this was found successfully, and if not, it returned an error. So instead of this code here, we basically want to use somehow the script I created, and this script provides some logic about detecting stop words in English and removing them. So if I want to use this script in my init file, of course I imported this file first, and then I can call it here with basically the text that was provided, and then I check whether the file was found, and then I process the text, and instead of returning basically a response that contained hello plus the string, I just return the text that was processed by my application. So it's as simple as that, and it doesn't require a lot of time, and you can do this similarly for other functions as well, or you can basically separate this by comma and call multiple functions and just nest them here in one JSON, nest the output from them. So after you do this, you need to, of course, run and test this locally, ensure that everything is working properly. And after that is done, and you're sure that everything is working correctly, you can deploy your application to the cloud, because so far we were running and testing everything locally. So deploying is quite easy from the terminal. You just need to run 4 commands. The first thing you need to do is connect to your Azure account, and you can do that easily with the credentials you created at the beginning. You need to create a resource group. When you're doing that, you need to provide a name from the resource group. And if you're located in Europe, the location will be Western Europe. This name should be unique. After we have a resource group, we need to create a storage account, and the storage account will store all the data that our function generates, like, for example, log files. Here we need to provide a unique name for our storage account, again, the location, and provide the name of the resource group we created previously. After we have our storage account created, we need to create a functions app, and this functions app will be the application that our end users will interact with. So the name for this application should be unique globally across all regions. And here we need to provide the consumption plan, the operation system type that we're going to use, in my case is Linux, and the resource group that we created previously. Once we have the function app created, we can finally publish our function to Azure and make it available to our end users. So you can deploy your function easily using these 4 commands in your terminal. Here you can see that I'm mentioning the consumption plan. So I'm going to briefly explain about scaling and hosting and why the hosting plan is important. So I use the basic hosting plan here, but if you want to get more deep into this and try to develop more complex application, keep in mind that you will have to read a bit about the hosting plan. because you might need to use more complex options, because basically what it does, it dictates like how application will be scaled, how many resources you will have available, and whether or not you will have support for some advanced features. So yeah, if you want to develop more complex apps after you're bored from this basic example, check the hosting plans in a bit more detail. So there are several things you need to consider when you are creating serverless applications, not just in Python, in any other language. The first thing is that it's a mind shift. You need to adopt a new way of thinking, because as I mentioned, we're thinking in terms of events and how to build event-driven systems and how to detect and process these events. So traditional architectural patterns that you are used to may not be suitable for like serverless applications. There are two things that work very well, of course. It's the event-driven patterns and distributed patterns. So keep this in mind. Another thing you need to consider is that serverless may not be right for every project. So you need to think about several things before deciding whether this is the right thing for you. The first thing is if you want complete control. So you need to keep in mind that you may not be able to tweak everything in the cloud. If you have constant workloads, then you might be better off if you use VMs, for example, instead of serverless, because I already mentioned you pay basically as long as your function is running, and serverless will be cheaper and will work better for applications that have periods of inactivity followed by high spikes of usage. So yeah, if you have constant workloads, check out other options like VMs. If you have very long-running functions, you will pay more. So serverless may not be the right option for you. Maybe you will be better off with VMs. So you should either try to make these functions shorter or basically just use the VM instead. Not all programming languages are supported. So if you use like some unusual programming language, you need to check whether it's supported. If you decide to create a serverless application, you need to try to optimize it to the billing model. As I mentioned previously, make the function shorter, make them faster. So this might take some time. And based at good practice is to log everything, because if something goes wrong, you will be able to figure out very quickly what went wrong. Okay, so let's take a look at some best practices that I often use when I'm building serverless applications that you can implement in your own serverless projects. The first one is quite simple: write functions that have reasonable name, especially if you come from a project that's not serverless and you want to make it serverless. This will allow developers to understand what this function does quickly and refactor it quickly to make it optimal for your new serverless application. Write functions that have a single responsibility. So this is important because it will ensure that your functions are, they run as fast as possible and finish as fast as possible. So if you have something like this, a function that does a million things, please separate the responsibilities in several functions. This is just a good practice in general for any software engineering project. Write functions that are shortly readable, of course, important because of the billing model. This will ensure that you pay as least as possible. Some red flags are that you look at the function and you cannot immediately determine what the function does. If you have deeply nested control structures, sometimes it might be necessary, but usually it's not, so try to refactor it. Check for duplicated logic, because you will pay more if you have something that's running twice. So related with the previous point, write short functions and write them in a way they will finish as quickly as possible, so you will pay the least as possible. If you use recursion, if you must, then use it and set the depth of the recursion. Otherwise, just avoid them, just to ensure that you will not end up in an infinite loop and with a function that will not finish in time, because there is a time limit of how long they can run. Write defensive functions. So what I mean by this is that assume that there will be errors and basically use assertions and preconditions to check whether the inputs are safe to use, and postconditions to ensure that whether the outputs are safe to use. Because remember, you will use this output in another services in the cloud. And of course, a good practice is to write tests before you write code to ensure that your logic is working properly. write idempotent functions. This means that you will properly validate input events and identify whether the events were processed before. And basically, if you provide the same input, the function should provide the same output regardless of like when this was run. So I will provide an example here. Imagine that you have this blob storage, and this blob storage triggers an Azure function that writes in two databases. If the writing to one database fails, you don't want to basically restart the process and write a duplicate in database one. So what you can do is extract unit attribute using the function and check whether this attribute already exists. If it does in both databases, you can terminate the execution. If it doesn't exist, you can continue the execution. And basically, in this case, you will only write to the second database and you will terminate execution to the first database. And in this way, you will ensure that you don't have a duplicate there. And yeah, finally finish the execution. You should write stateless functions because this means that function instances will be created and destroyed on demand. And if state is required, you can store it in maybe in an associated storage device service outside. Yeah, I don't think I should mention this, but unfortunately it happens quite often. Don't hard code secrets. There are other ways you can handle this. Just don't put them in your logic. So this was all for the best practices. This session was created in collaboration with ServerlessDays Amsterdam. I already showed you this repo, but basically you can we can go there. And here you can find well, the slides for this presentation as well as all the code I show. So you have all the instructions here for both Windows, Linux, and Macs. And basically you can try this out on your own. If you have any trouble running the code here or any run into any issues, please send me a message or send a message to ServerlessDays Amsterdam. We'll be really happy to help you and make changes if there are some mistakes, so please contribute. And yeah, that was all for today. If you have any questions, please let me know. I'll stay here and wait for them. And yeah, if you are interested in the workshop, please go through it on your own and address any questions to me. Thank you for joining. I hope you find this useful and informative, and I hope you enjoyed the next presentation. Bye-bye.
You need to, yeah, to go. Bye.
Can we stop clapping now? Okay.
It's not awkward at all, this.
I mean, I feel like this proves that we don't know what we're doing. We're just like a community of people who like to do things, do the best that they can. We're not professional, like, TV show producers or whatever. We're just people who have had a glass of wine already and are just trying to do the best with what they have at the moment.
You speak for yourself. Yeah.
Yes, I am speaking for myself right now. So let's go back to like real stuff. And thanks, Dana, for the talk.
Yes, thank you.
Of course. We wanted to talk a bit to you about PyLadies, because you mentioned that in your talk, and so far there have been no other questions. So can you tell us a bit about what PyLadies is and what you do?
Yeah, so PyLadies is a non-profit organization. This is the local chapter in Amsterdam. The workshops, presentations, and everything that this Meetup group organizes is organized by two ladies, Aliona and Demi. And I organized a workshop with them, which is part kind of this presentation. So it was basically introduction to serverless for minorities in tech, like for any people that need additional mentorship or maybe additional support. So PyLadies is a group that welcomes people from all levels of proficiencies in Python. So currently they're having a bootcamp. So if you're interested, please check it out. And if you can, like if you want to organize a workshop or maybe give a talk or be a mentor, please do that and support it.
That's awesome.
What's the URL again?
I can
Also, you look it up and post it in.
You can find PyLadies on LinkedIn. It's PyLadies Amsterdam, and the GitHub repo is just PyLadies, and there are many different workshops there.
Right.
Yeah,
Awesome.
I can share it on Discord if you're interested after the Q&A.
Of course. I mean, just to clear it up, because there's a confusion about this often, like, is PyLady something that only women can take part in?
Anyone is welcome. I think Aljona and Demi would like even to see, men coming there, because they would become like a bit more familiar with maybe some issues that women experience in tech, and also they can give like workshops and presentations, and I think it would be great if they decide to mentor. So yeah, definitely not like, please join, like, even if you're a man or whatever you identify yourself.
Great, that's awesome. So yeah, is there anything that you want to add to your talk? Maybe something that you didn't have the time to explain more in detail?
Well, I cannot think of anything. Maybe I would have gone in a bit more details about the hosting plans, because it's kind of important. But yeah, maybe it can be a topic for another presentation.
Okay, yeah, for sure. Just checking again if there are any questions from the audience at the moment. So, I mean, I definitely know that there are people watching. I see them. I see you all. But maybe it's just that your presentation was so clear that there are no questions left. But I mean, okay, so while we're here, and we just talked about it kind of while the recording was running, and you told me to just not mention it, but I'm going to mention it after all, because this is cool and we have the time now, is that we managed to get together a all-female event. Obviously not all female, but like the speakers are both female, the hosts are both female, and I just find that it's really cool that we made this happen without, like, we didn't have to like reach out to people and say like, I think it's great that you're a woman, so like, why don't you speak here? It just kind of happens just by virtue of the community, and I think that's great.
Yeah, definitely.
Can we get the emoji with applause one more time?
Yeah.
I mean, I hope that this proves to some extent that it's not about like actively having to like have a list of women that you go through. It's just like when you do the community work, when you show that you care about people and that, you're open and welcome and also have some visibility, then things will just come together. That's what I feel here. Cool. Do we have any last words or any more comments on that?
It's just break words, no?
No, not last words. That sounds horrible. No, I mean like any more input, any more. Oh, wait, there's a question. Perfect. So there's a question on Discord. Dana, what challenges did you face when building a big application, brackets with Azure Functions and Python?
Yeah, so there are few things that might be challenging. I would say, for example, if you have machine learning project, if you have like very big like dependencies in terms like of like size, I mean, so you need to find a way to deploy this. So also something else that might be a problem is the cold start. This means that it takes a bit before your function starts running. So depending on your application, this might be an issue. And also like sometimes orchestration can be a bit challenging. So yeah, these are like few things that pop up in my mind. But there are of course some ways to handle this, and Azure like keeps introducing like new features. For example, I would say like, for example, orchestration was a bit challenging, but now with durable functions, you can have like better orchestration, and you can also have longer running functions. So yeah, just need to like keep yourself updated with everything that comes up regularly, and basically adjust your project to that. Okay,
great. Thanks for the question, also ideable, and thanks for the answer, Dana. We're going to go into, unless there are more questions or any more things that anyone wants to talk about. So we're also going to be on Discord. Dana, are you also going to be with us on Discord?
Yes, I'm going to stay there.
Great.
So if there are any extra questions, please send it there. I will keep it answer.
Awesome. Yeah, exactly. So yeah, if you have any questions, put them on Discord. And we're going to go into a break for about 10 minutes. We're going to have a countdown also, so you don't miss us coming back. And yeah, see you then in about 10 minutes with our next speaker.
Bye. Okay, I'm going to turn off my camera now.
Yeah.
Yeah.
Hello, everyone. Welcome back to our meetup. Floor, would you like to introduce our next speaker?
Oh, absolutely. And before I introduce the next speaker, I want to remind everyone that we're in Discord and you can ask all of your questions or comments, be them friendly comments. So you can put them all there, either in the general channel or in the Meetup channel. So go to Discord and, join the conversation. Okay, so our next speaker is Marcia, and she's a developer advocate for AWS and the host of Fubar, a YouTube channel where she publishes content every week related to serverless in the cloud. And she's been designing and developing software professionally for 15 years and worked in all of the different stages of building, scaling, and performance software. Well, that sounds really good. Sounds like she knows what she's talking about. And today she'll be talking about CI/CD for serverless applications. Because to get the most out of agility afforded by serverless, it's essential to build CI/CD pipelines that help teams iterate on code and quickly release features. So, Marcia, whenever you're ready, let's go.
It's a recording, so just play it. Hello and welcome to this session on CI/CD for serverless applications. My name is Marcia Villalba. I'm a developer advocate for AWS, and I'm the host of a YouTube channel called Fubar, where I post 2 or 3 times a week videos about serverless and AWS. So if you want to see some hands-on tutorials, I recommend you to go and check them out. So today we are going to talk about CI/CD. And for the agenda of this presentation, I want to talk about the release process. That will be our guiding agenda. We will talk about the source and how to handle it for serverless applications, basically checking the source code, and you do some peer review. In the build stage, we will compile the code, run unit testing, do linting, create packages, and things like that. In the test stage, we'll be doing our integration tests, load testing, UI tests, and all kind of security tests and whatever we imagine. And finally, in the production, we will be deploying to production, we will monitor the code and detect errors if there's any. So we have the different names. We know the continuous integration when we automate the source and the build. We have this automated test, and basically we're checking code and we build. Then we have the continuous delivery, that it means that we have an approved deployed to production by a human, or then we continuous deployment that it's automated. So I will say that continuous delivery or continuous deployment is what we want to achieve, depending on the level of maturity of your application or the type of software that you are building. You might go for one road or the other. I think they are both valid and they are extremely useful both. So you want to automate your whole pipeline. So we are going to talk about that. But first, orchestrating this kind of release process, we have a service called Code Pipeline that will be our orchestrator. The Code Pipeline is a service that will allow us to do continuous delivery and will be helping us to do fast and reliable application updates. It will visualize everything really nicely in a dashboard that we will be going to see. It allows you to do builds, tests, deployment. Every time there is some change, it integrates with some third-party tools that we are going to see, and also with a lot of AWS systems. So this is an example of a minimal developer pipeline. We have 3 stages and 1 development environment. And in the different stages, we are going to do different things. The first one is the source, then we have the build, where we are building our packages, and then we are deploying to whatever, in this case is development. It can be our production. And for here we are using, for example, CloudFormation to deploy the artifact, and we have some kind of Lambda testing with custom actions and integration tests. And this is a more realistic pipeline where we have 5 stages and 3 different environments where we're going to deploy. We have again source and build, but when we have testing, staging, and production with different kind of set of tests for each of the stages. One recommendation I always do is to have different AWS accounts to hold your stages. The dev account, the staging account, and the production account. This is always good in order to separate the different resources that you're using, and if you have any problems with your limits or also to the security, you have different kind of sandboxes where to work to. So I recommend you that you have 3 different or as many as kind of environments you have, and there you can use code pipeline again to integrate to multiple accounts with no problem. So code pipeline will kick off a release when there are some things that happens, either a branch changing a code commit, that is the AWS service for a repository of source code or GitHub, or we have an S3 bucket that a folder or an object change, or we have a CloudWatch event, or even a cron job. So there can be many reasons why this service kicks off a release. So this is how the pipeline looks. This is an example pipeline that has 4 stages. We have the source, we have the build, and then we have the stage and the production. And each of the stages have different actions inside that are doing different things. So this is the pipeline that we are going to build during this presentation. And I will show you how to build it with infrastructure as code. So this is the pipeline, not the same that I showed you before. This is an example, but let's look at the different components. So the first thing we have is the stage, and this is the kind of main stage. We have a source, build, deployment, production, testing, whatever you want to name them. Inside each stage, we have actions. Actions usually have a name and information on the different actions. Some of the configurations of the actions, like the artifacts that it consumes and it produces, and also you need to give an order for sorting these actions in the stage. So if we have in this case change sect is 1, then execute changes is 2, and run stuff lambda is 3. We want to keep that order. We could not do it the other way around because it doesn't make sense. But if you have 2 things with the same number, they will run in parallel, so that's pretty neat. And this is how we define an action using CloudFormation if we want to build this pipeline as infrastructure as code, as we are going to do. So here you can see that we have the first is the name of the stage, and then we have the definition of the actions. In this case, as we are defining the source, there is only one action that is called source code repo, and there we define that is a third-party GitHub repo for the source code, and we put the configuration that we need to know who is the user, the owner, the repo, which branch, and plus some OAuth token for authentication to our repository. And then we get some output artifact that is the source code as a zip, and this is the order. So this is how the pipeline looks, and here we have the 4 different stages. I will leave you a link for this in GitHub, so you can go and check it out, so don't worry. And we have the source that we saw, build, stage, and prod. So if we open source, then we will see that exact thing I showed you before. This is a GitHub action, and it's getting the code as a zip. That's the output. And this output is passing it to the next stage, that is the build stage. And in the build stage, we are going to build our package, our artifact, and it's taking the source code as a zip that we get from GitHub, and it's passing it to a project code build, and is returning an output that is the build artifact as zip that is going to be passed to the stage and prod. So here we are building once and deploying in 2 different stages, and that's how it should be. You don't want to manipulate that artifact. So now we build, and we are going to go to stage, stage, and there we have 3 different actions: the create change set and execute change set. Those are CloudFormation actions. One is creating the whole template with all the right things and passing all the right environmental variables and blah blah blah, and the second one is running that in the CloudFormation service and making sure that everything is up and running. And finally we have the Lambda run test that is running Lambda integration test. And the production looks very similar. Instead of having the Lambda integration test, it has first a deployment approval. It's a manual approval that we need to give a thumbs up or thumbs down if we want to continue. And then the deployment using CloudFormation. So if you want, the code for this pipeline is here. I will be showing a lot of demos from the GitHub repo. So just take a picture of this screen and you can access it later on. So now let's go to the first part of our release process, that is the source. We are going to talk about the code and also about the infrastructure. Infrastructure as code is something super important in serverless, and for that we are going to use mostly CloudFormation. CloudFormation is 2 things. It's a common language for provision your infrastructure resources into the cloud, and also it's a service that allows you to build and rebuild your infrastructure and applications without doing any manual work. So we are going to use that. On top of that, we are going to use AWS Serverless Application Model, or SAM, and that's an open source framework for building applications on AWS. These are for serverless applications, and it's built on top of CloudFormation. It provides some shorthand syntax for functions, APIs, databases, and event source mappings. So if you are building serverless applications, this is a great way to go. Using SAM, it will help you and it will make you very fast. Basically, at the end of the day, it transforms this SAM that looks very CloudFormation into CloudFormation. So you can deploy as it will be a normal CloudFormation application. And also you can attach CloudFormation into the SAM. So it's great. This is an example of a SAM template. So the first part, it will tell you CloudFormation that this is a SAM template that needs to be transformed. Then there is like 20 lines of code that will create a Lambda function, an IAM role, an API gateway, and everything is defined there. We have the function definition with its configuration, then we have the permissions for the function, we have the API gateway definition that is at the same time the event mapping definition, and then finally we have there 2 lines that are creating a DynamoDB tables with 5 read and write units. So it's super simple to get started with SAM. With SAM, you can use the SAM CLI to package and deploy SAM templates either from your computer, from Code Pipeline, or from Jenkins. And this is something I will show you when we are building our SAM applications. If you're doing it from your computer, I totally recommend you to use this command called SAM deploy guided that will set up everything for you, super simple, and then deploying some applications from your computing becomes very easy. Also, SAM provides a lot of help inside the template. For example, the SAM globals that allows you to have a place where all the global information for all your functions is defined. Here we can have things like the runtime, the memory size, the timeout, and all these kind of things that are shared between the different functions, so you don't need to repeat that information over and over again. Then we have the SAM policy templates, and this is something I like a lot. These are basically policies that are managed by AWS, and they are extremely useful for SAM. And for example, this one, it's everything you need to have CRUD access to a DynamoDB table that you define there. So you don't need to create those statements with the policies, allowed, resource, and all the stars. And no, there is nothing like that. And if you want, you can find all the policies in this bit.ly link, and I totally recommend to use them because sure, there are some services that are not here or some use cases that are not here, but most of the things that you can do and you want to do are defined here, and it's a very safe way to give access to your functions to the right resources and not anything extra. Then SAM provides the Lambda environmental variables, and I think these are really good. Environmental variables are basically key value pairs that you can pass information dynamically to your function. And this is very important that we can have for one template and deploy it into multiple environments. So this is something we want to use, and we want to use a lot. So basically, if you want to pass a environmental variable to your function, you just need to add in the function this attribute environment and pass the variables there. This is very useful, so you don't have the table name inside the code. For example, if you're calling a DynamoDB table, you have the table name in your infrastructure defined in your definition of your infrastructure, and then you pass it to the function. And if you change the table name, you only change it in the infrastructure, and you don't need to change it in the code. And this is how the code looks. That basically this is JavaScript. You just need to get it from the process.m and the name of the variable inside a function, and that's how it works. It's super simple. And this is available also for other languages, not only for JavaScript, but I'm just showing you a demo with JavaScript. Then with these environmental variables, you can pass them through your code pipeline when you're defining an action. So for example, this is the create change set. So when we are building the template to be deployed in a CloudFormation, we can attach new variables or put values into existing variables, and then we can deploy different the same template into different environments with different table names and function names or whatever we need. So in this case, we are overriding the environmental variable myEnvironment to the right staging or production, whatever environment we are. And then inside the SAM template, I create a list of different variables with different allowed variables, and then I'm creating a mapping of the resource name. So here we could have queues and tables and functions and API gateways, whatever we imagine, we can find them here. And then when we are naming those resources, we can find the name in this resource name according to the environment that was passed. It looks complex, but believe me, when you understand this, it saves you a lot of time, and it makes you extremely powerful to deploy into as many environments as you want without hard coding one value in your code. So this is extremely reusable. Then for the source, we have code commit. That's a fully managed source control service that is Git-based, and it's inside AWS, so you could use that one if you want to. It's very similar on GitHub in a lot of things, but it's inside your AWS account, so for a lot of people it's very easy to jump into this service. So now we move to the release process stage build, and here we are going to automatically kick off a new build when the code is checked in. We are going to test and make everything is creating an artifact in a nice way and have our artifact ready for deployment. And if there is any error, we are going to return something. For that, we are going to use code build. And this is a managed service that will help us to build applications. We can build non-serverless applications as well. In this case, we are using to build our artifacts for our functions. It scales, and you can do in parallel builds or as many as you want. It's totally serverless. You pay for how much you use. It integrates with the parameter store, so you can pass variables from there, and you don't need to manage those services. And here, how it works, you need to find in the root folder of your application, the one that you're going to build, a file called .buildspec. And there you can write something that looks like this, something very simple, or something more complex like this. I know this looks complex, but this is something that we will be using a lot in different production systems. So this is basically the machine that you get for code build is a Docker image that doesn't have anything. So first stage, you need to install things like curl, you need to install Node, you need to install AWS CLI, SAM, the application itself. So the first step, the first phase is to install everything you need. The second phase is to run the test and make sure everything is fine. If you have linting, run them there. The third stage is to build, so you're running your build commands, and for that I'm using the SAM CLI here that I installed. I'm using some build and some package and things like that. And with that, I'm creating the artifact that is called package YAML, and that's our artifact that we are going to pass to the next stage. And in the last phase, we can do things like send notifications, add tags, or whatever we want. I don't do much in there. And finally, we have the definition for the artifacts. You could be building many serverless applications at once if you want, but here I'm just building one, and I have that artifact that I want to save. So this artifact is the one that I'm going to use in my next stage, called stage, when I'm creating the change set. So I need to pass the path for that artifact. So have that in mind. And then we move to the next stage, that is test. And here, usually testing has been done always in build stage, but in the serverless world, we can do it anywhere. And I think integration tests are way valued in serverless, so we want to do as many integration tests as we can. So that's why I moved the kind of testing from build to this other stage, that is staging or testing or whatever you want to call it. So here we can test in the serverless application in multiple different places. We can do code reviews in the source, then we can do linting and unit tests, and in the build phase we can do, and now we get into the staging and testing phases where we can do mock and stuff integration test, security test, application deploys test. We can run our applications and get third-party services that provide specific tests like this run scope that will test our APIs. Then we can do safe deployments with canaries and test our deployments. We can do post-traffic tests, and we will go into all these details, and you can see how much you can test and all the different tools that you have in your hands to test. So if you want to use Lambda to perform integration tests, you can define a Lambda function that looks like this. You write your integration tests. They can be against a Lambda or I don't know, API gateway or whatever. You can get artifacts, consume some values that you get from other stages, so you can ingest that as well. You can get them in your event, and you do your integration test. And when you finish your integration test, in order to connect this Lambda into your code pipeline, you need to pass this put job result success result into the code pipeline. This is if everything goes well. If things go bad, you need to put this job failure result, and there you will get in your code pipeline a red or a green tick, and they will move forward. So this will help you to integrate Lambda as your integration test mechanism. So this is great. And then in your definition of your code pipeline, you basically, the only thing you need to do is to put a function name, and you can put an input artifact if you need some names or something that is generated automatically there. So it's very, very simple, and this makes it very powerful that you can run your integration test also in a serverless manner. If you want to find more information on how to do this, I recommend you to go to this link and check it out. Also, you can use third-party services to test. These services provide all kind of specific testing, like UI testing and performance testing, API testing, and there's many of them available, and they keep on adding new ones. So if you want to find more, go into this link and find the exact information that you're looking for on how to integrate these services. I think these are a great addition, so you don't need to write everything from scratch. If you want to do manual approvals, meaning that some human needs to come and give a thumbs up or thumbs down, this is if you have some manual QA or you have some release manager, you just need to get that box in your pipeline that somebody will need to come and review it. And the box looks like this, approve or reject, and you can put some comments. It's basically adding in your pipeline this action, super simple, and that's all you need. Then if we want to do safe deployments, that is immutable deployments, or how you call it when you're migrating one environment to another, then you can use co-deploy. Code deploy will help you to deploy your code, and for serverless, sure, you can do with some deploy, poof, they're up. But if you want to do something a little bit more elaborated or more articulated, I think this service will work very well for you. So here you can perform safe deployments. There are two types of the deployment. There is the canaries and the linear. Canaries meant that you are sending traffic for a fixed period of time. For example, 10% of the traffic is sent for 10 minutes into the service, and then if under 90% is sent to the old service, and if everything goes well, after 10 minutes the traffic is all shifted to the new service. And then linear means that every, for example, 10 minutes you're moving 10% of your traffic to a new service. And these two ways are great, and also it has the all-in. And basically this type of deployments, how they work is that they create a new environment. So you will have the new Lambda deployed, and the traffic will be shifted from the load balancing perspective. So the old system still exists and it's very fast to roll back. So if you want to use safe deployments, you need to add some things to your SAM application. First, you need to have an alias. Alias will help to differentiate your new function from the old one that exists there, so you need that. Then you need to decide what kind of deployment you want to do, if you want to do it all at once or linear or canary, and what kind of mechanism. Then you can define some alarms, and these alarms are really good. So for example, if you're running canary or linear, then the alarms are monitoring your system all the time, and if there's something that triggers an alarm, then your deployment will stop and roll back, and you will know what is going on. You can have 10 alarms maximum, so there's a lot of things that you can monitor, and it's great. And finally, you have your pre and post deployment traffics, hooks. These are Lambda functions that are triggered before, in the case of linear and canary, before you are passing all the traffic. So they will run if everything, I don't know, they will do some tests or make sure that everything is good. Then all the traffic will be moved, and finally they will run something else and make sure that everything is well. So then the safe deployment can finish. So these are really handy. And so this is an example with some drawings. So we have the API gateway sending events to Lambda function with the weighted alias live, and we have the Lambda version 1, and then we deploy the new version, that is version 2. Now we are using canaries, so we are going to have maybe 10 minutes of traffic, but before we are running the pre-hook validation Lambda with to the version 2. If everything goes well, then we start moving 10% of the traffic to the version 2, while the 90% of the traffic goes to the other Lambda. We check 10 minutes. If there is no alarm, then we continue to the next phase. If there is an alarm, we roll back. And it's very fast to roll back, because this is just basically the version 1 is still alive, it's still there, so we are not replacing the existing environment. Then 10 minutes pass, we move all the traffic, and then we run the post traffic hook, and when everything is continued, then we are done. So this is how it looks in our code deployed, and we have one deployment that is in process, and if we open it, we can see that the pre-deployment validations has went through. Now the traffic is shifting. We are in the point that it should almost be shifting, so you will see how it goes very fast. 90% of the traffic is in our original Lambda, and 10% is in the new one that is replacing, and this goes for 5 minutes, so it should happen pretty soon that the traffic is shifted. And let's see. When it shifts, what it will happen is the post-deployment validation will run, and all the traffic will be moved to the next stage. And now it happened, so that's good. Another way to do this load balancing move of data is use this way, target groups for application load balancer. This allows you to do more or less the same thing. So you can do blue-green deployments, in-play deployments, and things like that. So it works in a similar way. You have two different lambdas with different target groups, one for the blue and one for the green, and you can define how much traffic you are going to pass from the load balancer perspective to each of the target groups. And this is good. There is no need to do some DNS changes, so it works very well. And if you want to define that, you can basically configure it like this. You need to pick first the forward action, and then define the two different target groups with the desired weight. And then you need to configure the request from the client to always serve to the same target group. So have this kind of a sticky kind of cookie or something that is always serving to the same target group. And you can define for how long you want to keep this up. So this is pretty nice way. So you can do A/B testing, for example, here. For example, the client A will have the experience A for 4 hours, and the client B will have the experience B for 4 hours, and then you can validate your results. And finally, we have the production, and here we want to deploy the new changes that we have in staging. We want to make sure that everything goes to production safely. We want to deliver to customers faster, and this is something that we kind of achieve already with the safe deployments, but we can also need to add the monitoring and observability in place. I will not talk about these two things here. This is another particular talk, but I want just to mention these two services that can help you out: CloudWatch and X-Ray. CloudWatch, I'm pretty sure you know it. It collects monitoring and operational data in the forms of logs, metrics, and events, and you have the alarms as well there that are very, very useful to make sure that everything is working fine in your system. And X-Ray, it helps you a lot. It provides trace on end-to-end requests traveling through your application, and in serverless this is very, very critical because it's very hard to see, if not the whole end-to-end picture. So now to wrap up, let's look at some of the best practices when we are working with CI/CD for serverless. The first one, I mentioned that it's good to have 3 different or more AWS accounts, one for each environment that you're going to deploy to: dev, beta, prod, dev, staging, prod, whatever you like to call them. Have one SAM template that allows you to deploy into multiple accounts, so you don't need to handle a lot of code and a lot of complexity. To reduce complexity, one SAM template, 3 AWS accounts. In each of the accounts, you need to have some kind of management for secrets, so you can use the secret manager or the parameter store with encrypted data. That works very well. And you will have different resources with different names that you will define in your SAM template, and you will pass through in the building process. One way that you can help with the share of code in your functions is to use layers. Layers are a great way to share dependencies and have a dependency kind of synchronization. So if you have in your organization some pieces of code that you want to keep everybody using the same version around your organization, or the same piece of software, you can pack them in a layer and they will help everybody, and everybody can sync in those layers. So layers will have their own deployment strategy, and they will be deployed in a different kind of pipeline than the lambdas per se. And then everybody can basically use different layers by just calling the Amazon resource name, the ARN for those layers, and they can pack until 5 layers in one function. So before layers, what will happen is that we have these different functions that they are all using library A and library B, and we have this duplicated, and if tomorrow library A has a new version or has some security patching, then we need to make sure that everybody updates to library A. But if we have everything in a layer, then we can have a team that is taking care of these layers for each individual library, and then the functions just need to keep up with the new library version. And in one layer, you can cap as many libraries as you need, so you could build little packages or bundles depending on what your functions are doing. If you want to get started using code pipeline, code build, and all these services, one thing that you can do is to go to this GitHub repo, and here is a working template that you can try it out and explore. and I used this when I was learning this service. I like it a lot. You can also go and create an application in your Lambda. If you go to Lambda, then there is this application tab, and there you can create an application, and that will create some template for infrastructure as code for your application. It will create some CI/CD code pipeline for you with everything, and you can basically clone and do all kind of things locally and try it out locally as well. And then when you push to GitHub, it will just work. So this is a great way to get started. And also in this talk, we mentioned all these different services. For the source, we talk about code commit and GitHub as well. That's not an AWS service. We talk about code build in the build phase. We talk about in the test, we talk about code deploy, and all the different services like Lambda and manual approvals and the third-party integrations. And all of that is handled by the code pipeline automatically. And finally, we have in the monitoring stage, X-Ray and CloudWatch. So this is the pipeline. Thank you very much for listening to my talk. You can find more information in my YouTube channel. I have made a couple of videos on this topic, and I have made around 250 videos in other topics, so you may be interested in checking it out. My messages in Twitter are always open, so you can go there and ask me questions about this topic. I will be very happy to answer. And you also there can find the GitHub, my GitHub profile, and all the links for this particular talk. Have a great day, and thank you very much.
Now.
Yay! Thank you, Marsha. That was great.
Thank you.
Let me just go real quick and see if we have any questions. Amazing talk. Sarah's really happy.
Thank you, Sarah.
So, all female Serverless Days Amsterdam. I love it. Of course, it's not exclusive. Like we invite everyone to join us, but it's just so great to have some like great female visibility.
Definitely.
I'm just really happy about it.
Yeah, I was very happy when I saw the previous speaker that was also a lady. I was like, yes.
Yes. I love it. I just love it. So yeah, we've been talking a little bit already while the recording was running about what you do with your YouTube channel. So I would love it if you could tell us a little bit about how you got into that. How did you get started, and how did that feel for you to do that?
Well, I got started like 2016 when I was starting my serverless journey. So I always had a tech blog. I always liked to write, and nobody was reading that blog whatsoever, but I always like to record all my stuff. And then I started this serverless migration, and it was very hard to explain to my teammates because they were all everywhere. It was very hard to get them in one room. So I started making YouTube videos explaining things so they could watch them on their own time. And there was no YouTube content in 2016 about serverless. So people start finding me and watching my content, not only my mom. So that became a little bit like, oh my God. And I was doing it just like now and then, not even regularly and not with nothing. Like it was just like hello world and how to deploy a Lambda and things like that. And then I went to this serverless conf in London, and there was all these AWS people there. And I don't know if you know Danilo Poccia, he's the serverless developer advocate for AWS. And he was like, oh, that's the YouTube girl. And I was like, who are you?
Awesome. Was that like a big thing for you to like record yourself and then watch yourself, and what do you say? How do you come across?
I don't know. I'm a shameless person in a way. I don't have much problem on putting myself out there. But it's still, now I've been doing this since 2016. It's still very hard for me to watch myself and to hear myself. But I don't have any problem. And since the beginning, it was awkward because I didn't know how to use the equipment and how to edit and how to speak I still don't know how to speak English properly, but by that time I speak worst. So it was very hard to put my ideas out, and I think I learned a lot on how to properly speak.
You also have some videos in Spanish, right?
Oh yeah, Spanish is my native language. I knew how to speak before starting the video, so that makes it way easier. So I have a lot of fun recording in Spanish. Now I started a podcast in Spanish. So if you're a Spanish speaker, you can go and check it out. It's AWS en Español. We talk about all the news and all whatever AWS in Spanish with another lady. So it's a female power blog podcast.
So cool. I really love that also that you're doing it in Spanish, so people who maybe are not that good with English for whatever reason.
I think in the tech community in general, people can understand English for a tutorial, and sure there is all these generated subtitles, and if you have the code available, like you can follow along. But for longer format, like interviews or chats, I think it's very hard to translate that with. Like sure you can make proper subtitles, but it doesn't come along that well with generated subtitles, and if you don't know English that well, it's very hard to follow. So that's why I started the content in Spanish. That is, if you check the videos, they are usually 1 hour long or in that kind of ballpark, because I like to make longer format in Spanish, so the people watching can get more value on one video.
That is so cool.
But I'm
do you have
3 videos a week, so in Spanish and English.
Do you have any videos on how to do videos?
No, I'm
Too
not that
bad.
good. I'm every time I get the question, how you do your videos, how you edit your videos, and everybody's like, what the hell? You're so low tech. Yes, I am. I use my iPhone. I use a crappy microphone. I don't have any green screen or anything. I just use a wall. I edit with iMovie. I don't have anything like basic stuff, and I've been running the YouTube channel now for almost 4 years with the most basic equipment. So
Right. It's the content, right?
and I think there is always levels. If you have a very crappy audio, definitely it shows and you can see it in the video. But if you have a decent audio and a decent phone to record, nowadays all the iPhones, for example, or good phones, they have really good quality. So you don't need to invest in a really great equipment to get started. You just can use whatever you have in hand. And I do most of my podcast and interviewing with a webcam. Not the one from the Mac. I have this Logitech. So you don't need expensive equipment to get started. What you need is consistency, put in the effort, and consistency.
Awesome. So what are other events that you can recommend? Maybe events that you're speaking at? Where can we see more of you?
I will recommend definitely to everybody that is interested in AWS to join the AWS Online Summit. I will be giving a 1 hour talk there. Well, it's 2 talks of 30 minutes, but they go together. One is a theoretical talk, and then it's the demo. And there I will be talking about Amplify and how to get started with it. The summit has 55 talks, so that's pretty cool. 11 tracks. So from I'm new to the cloud and I want to get started, to I'm an architect, to developers, I just want to see code and no slides. Like there is, I think, a session for everybody. Besides that, then there will be a place where you can ask questions to the architects in AWS. So if you need, if you have some questions or you want to get some answers or you want to talk with the speakers as well, we will be there. So I think it's a great event. It's 17th of June, and I will put the link in the Discord chat. So if you want to register, it's free, and it will be in English, but there will be subtitles in Italian, Spanish, French, German, and some other language. I don't remember. There was
multiple languages. That's awesome. Yeah, if you could share
Spanish.
Spanish, yes, Spanish, Italian. Well, those.
Fantastic. I'm seeing that someone's typing in Discord, so I'm going to have to stretch that conversation until they finish typing because there might be a question in there.
Maybe you can introduce the networking bit already.
Which networking bit are we talking?
And we have a networking chat thing afterwards.
Oh, yeah. So, I mean, yeah, okay. So What Flora is alluding to is that we will do a video audio chat on Discord to, yeah, as I said before, because you need like at least one hand for your drink, so you can't type with both your hands. So we will try and do like a face-to-face after party thing on Discord later, which we will close when the last one of the organizers leave, because we want to make sure that everything's above board there. So we're not going to leave anything unattended here. The question is there. Fabulous. So the question is, from your experience, what is the best way to deal with big node modules and Lambda? Is it recommended to bundle your Lambda functions?
Well, one would practice that you can use is the layers if you want to have these node modules distributed if you are using it in multiple functions. If not, another way is to try not to have a lot of node modules, as little dependencies that you can have. Sometimes, for example, it's very common to load the whole load dash, for example, and then you're using one little function from there. So try to be conscious on the dependencies that you have, because as you all know, the bigger the dependencies are, the slower your Lambda will be to deploy. So that's something I will always try to analyze. And sometimes it happens that you are just deploying the code of multiple functions and they are all coexisting together. So maybe trying to separate the functions and separate the dependencies as well. So you have one function with each dependencies and not share the code so much. That also sometimes helps. So every function has only the dependencies that they need, because that's sometimes quite normal that people are sharing code a lot. They only have different handlers, and then the whole shebang is the same for multiple functions, and then everything gets loaded in the application. So be conscious about that. Layers help not to make your deployment faster, because they still need to get to your application. So
yeah. But with layers, you all share, like all the functions share the same dependency.
Well, you can with layers, you can basically define all the dependencies. For example, if you have multiple functions that they are all using the same, and you want to make sure that they are all using, like, I don't know, the same load dash or the same whatever. So you can put everything inside a layer, and then there is someone organizing that layer and deciding, like, now I will update it. So it updates all the versions, and then it publishes a new version of the layer, and everybody using that layer can update to the new version. So it's a way to handle that. But then when you deploy, you're still deploying that bundle of dependencies. So still takes time. So
yeah,
there is no magic source. You need that code.
Right. You can't have your cake and eat it too, pretty much.
Yeah. Sometimes you can play with lazy loading and things like that. If you can do that, if you don't need all the dependencies loading at the beginning, you can try to do some magic and call it afterwards whenever you need it. But I think then you have a too complicated Lambda function if you're trying to do all kind of mess with your dependencies. Just try to have cleaner Lambda functions that do smaller things, and then you don't need a lot of dependencies.
Yeah, just write clean code.
Yes.
Just write clean code, and all your problems are gone. Just be diligent.
Yeah, kind of. Yeah. The same with unit testing.
I think with Lambdas, I find like integration testing might even be more important than unit testing.
Oh yeah, definitely. But I think sometimes people are like, how I can test locally, and it's like, you don't really need to test locally. You can write good unit tests to make sure that your business function is working, and then you do integration test and you make sure that your configuration is working, because you don't need to test that Dynamo is up. In general,
right.
Dynamo is up, and we trust that Dynamo is up, because if not, then. But maybe you want to test your configuration between your Lambda function and Dynamo, or your S3 to your Lambda, if that's the trigger is working, and there is where you want to run your integration tests.
Cool.
Yeah, and now I think it's super easy if you are using, for example, this code pipeline, what I was showing in the demo. you can write Lambda functions that are running those integration tests. So there, it's like you can put it in different places of your deployment, and you can make sure that they're running, I don't know, after you have deployed the function, before you have deployed the function. So it's very easy to.
Yeah, great.
Yeah.
Cool. Flor, do you have anything to add at this moment?
If I can have something to add to like the wrapping up. I really love the talk. Thank you so much.
Thank you.
So we're moving over to Discord again, right, Lian? So I guess you should introduce that. But before we move to Discord, maybe we can do a little save the date for the next meetup.
We can do that, which will be, if I'm not mistaken, the 2nd of July.
Yes.
And we're going to have a super, super special treat because we're going to have like a AWS Azure showdown type of thing with the brothers whose last name I forgot now.
The Bryan brothers.
Bryan brothers.
Oh yeah, exactly.
They're like twin brothers, and it's so confusing.
They're twin brothers also. Wow.
Yeah.
And then they have a sister who also works for AWS or something like that.
Oh, I don't know that.
I think it's older brother, but you know.
They are.
No, okay, I'm getting confused
security,
now.
and they're both developer advocates. So.
Yes.
Oh, okay. So we're gonna have both of them, and we're gonna do some like fun, like sibling rivalry thing, which we haven't really decided yet, but it's gonna be great. So you can save the date for the 2nd of July.
It's basically sort of their Christmas dinner, no? Like we'll just be sitting in on their Christmas dinner, and then bickering together. Sounds wonderful.
Maybe we should probably not throw in anything political then.
Right.
Yeah. I mean, it would be interesting to see someone else's family falling apart for once.
Okay. And with that, can you tell us how we go to the networking part?
Okay, but apparently my Christmas dinners are different from yours. So on that note, yes, we're moving to Discord now because we want to like talk to you all, especially Ideable, who has been thank you so much for asking questions and being part of this conversation. Really love it. So hope that you will join us for the networking channel, which I'm going to open immediately after we close this call right here. And so Marsh, sorry?
What's it going to be called? What is the thing?
It's called networking.
It's called, well, that you could be able to find that, yeah.
Yes, I think so. It's the only voice channel. Right, and then we'll all be there. Marsha's going to be there. Dana's going to be there. Maybe a little bit later. Mark kicked himself out of the call again, who's been doing our tech. Thank you so much, Mark. He'll also be there. And yeah, let's share a drink because I've been the only one drinking so far. And I would love to share that with the community. So, Mark, now that you're back again, hopefully, yes. Are we ready to? Okay, cool. You always shake your head for. I don't know. Is that a positive, encouraging kind of shaking?
It's a positive thing, definitely.
Okay, cool.
I was wondering, did you screenshot it now where Mark was throwing Mark out of the call?
No, I was too busy talking. Sorry.
That's fine.
Okay.
I need a new laptop. Definitely.
So thank you all for joining us, and I hope to see you now in the networking chat. And yeah, like stay safe out there with everything, and hope to see you again on the